As we've seen in this chapter, the non-graphical information of an HVAC design is often more important than the graphical information. In the previous video, we explored some of the reports and schedules available in Revit. In this video, we'll look at another one, which is schedule and quantities, and how to use them for systems analysis. We want to use schedules to identify ducts and pipes in the HVAC systems with velocity and friction outside the design target range. So let's start with the ducts. Go to the Analyze ribbon. From the Reports and Schedules panel here, click Schedule and Quantities to launch the dialog. Then select Ducts, give it a name, so leave it as Duct Schedule, and click OK to proceed to the Schedule Properties dialog here. So here's a list of the duct parameters, including project and shared parameters if available in the project. You can even add project information parameters from here as well. So for this schedule, we'll add the following. First is the system name. Just double click on it or click the green arrow here. Then we'll add the family and type. Then we'll add section, add size, add velocity, friction, and flow. Next, we'll go to the sorting and grouping tab here. Then we will sort by system name, enable header, followed by family and type, enable header, followed by section, and then by size. Make sure itemize every instance is checked. Then we'll go to formatting tab and we'll make system name and family and type hidden fields. Then we'll activate a conditional format for velocity. So select velocity and click on conditional format. For here, we want to highlight values that are not between 2.5 meter per second and 7.0 meter per second velocity. We want to highlight them in red in the schedule. Then for the friction, we want to do the same. We want to highlight the ducts that are not between 0.6 and 1.0 Pascal per meter for the friction. I want to highlight them in red as well. So when you're done, click OK to generate the schedule. So here you can see the ducts that are within every system. You can see those with velocity of friction outside the target range highlighted in red. So you can see that largely this is looking fine. For the ones with lower velocity of friction, you can reduce the size slightly and vice versa. So if the friction is too low, you can reduce the duct size to increase the velocity of friction and vice versa. Now, depending on the project tolerance, you can ignore the ones that are close to the range. But for some that are too far, for example, our maximum friction that we need is about 1, but this one here, you can see that this is very far away. So for the ones like this, you can select the row, then you click highlight in model, and this will open a view showing you that particular duct. So initially we wanted to have 2 terminals here, and eventually we changed it to 1. So because of that, this duct size, we forgot to resize it properly. So in this case, you can either, change the duct size by yourself by changing it from here, or you can even use the duct and pipe sizing tool. So from here, you can see we want to size this using equal friction of 1.0 Pascal per meter. And once you do that, Revit will resize it. So you can see change it to the same size with this, which is fine since we have just 1 terminal here. Now, once you go back to the schedule, you can see that that is no longer the case. So you can use the schedule to ensure that all the ducts have acceptable velocity and friction. So these ones, for example, we need 2.5 and 0.6. They are very close. So depending on the project tolerance, this 2.5, 2.4, very close. So you can just trade off some of this. And for the ones that are also very close, you can use things like dampers to cushion the friction effect and all that. So you can use the schedule to analyze and make sure that everything here is acceptable. So next we will do the same for pipes. So we go back to the analyze ribbon, then we'll click the schedule and quantities button. Then this time we'll choose pipes. Just double click, give it a name and click OK. That will take you to schedule properties dialog. So similar to docs, we'll add the following. We'll add the system name, add family and type, add section, add size, add velocity, add friction, and finally flow. Next, we will go to the sorting and grouping tab, and then we will sort by system name with header enabled, then by family and type with header enabled, then by section, then by size. Make sure itemize every instance is checked. Then we'll go to formatting. Just like docs, we will make these two hidden fields. We only need them to sort and group. Then we will activate a conditional format for velocity. So select velocity, go to conditional formats and highlight the pipes that are not between 0.6 meter per second and 1.2 meter per second. That is our design target range. So we want to highlight these ones in red, and then you click OK to generate the schedule when you're done. So again, you will see the pipes in the projects that are not within this range. Actually, we've not done the pipe or duct sizing for our pipe systems. So this is just the out of the box analysis that we have, or the out of the box values that we have. So just like I mentioned in the previous video, you can just select these sections of our systems and we can begin to resize them either manually or the duct and pipe sizing tool. So I can select these ones here and then I'll highlight them in model, and that will take us to where this is. So for this, I can as well just select everything within this area like this, and I can use the duct and pipe sizing to resize everything. So you can see how Revit have resized all that. If you also pay close attention, you might want to change some of this to meet commercial sizes. For example, this is 40 millimeter and this is 32. So if I want, I can just reduce this to 32 and whatnot. But now if I go to the pipe schedule, we notice that these values have changed a bit. I'll leave this for now and I can move to the next one here. I can select this, highlight in model, and I can also just go straight and resize them. So you can see the value we are using 1.2 meter per second. So I can just quickly keep combining these two tools, the schedules and the duct and pipe sizing schedule. Now you can see those ones have cleared. I can also quickly do the same for this section. So this buttresses the fact that you don't have to use the entire loops or layout to size your ducts and pipes. You can just pick a subsection, which is what we're doing. We just use the schedule to find out the areas where we need to resize, and you can quickly use that to resize your ducts and pipes. So I quickly use this to go through this entire schedule. So now we've used this schedule to make sure that almost all the pipes in our model are within the design target range, which is 0.6 to 1.2 meter per second. At the moment, we have just two areas in the entire project that seem to have some issues. So when you select this, you see that this actually highlights the plant room, the pipes that are connected to these pumps. If you also highlight the other one, which are these ones, you notice that these also are the same. So this is for the chilled water, this is for the hot water supply and return. So these are the kind of scenarios whereby you, of course, in a real project, you have a lot of pipe accessories. You have a lot of pipe accessories that can help you to increase the velocity of flow, and sometimes you might need to use this to resize the pumps and all that. So but the bottom line of this is you can use your schedules to begin to dig into your design and begin to make improvements. So already we know that with this kind of scenario, we probably might have to increase our pumps or add a lot of accessories here to increase the velocity of or water flow that is going through these pipes. So as you can see, there are multiple complementary tools that are available in Revit to investigate your HVAC designs. I mean, in this video alone, we'll be able to combine schedules and combine it with duct and pipe duct sizing tool. Of course, after you've generated these schedules, you can always go back to your analyze ribbon and generate new sets of duct and pipe pressure loss reports, and you can still use the legends to further analyze the flow and whatever that is happening in the various ducts and pipes. So there are just a lot of tools in Revit that you can use to investigate the parameters that you have within your design. So the application of schedules for systems analysis in Revit is also numerous, considering that you can create custom parameters which can be project and shared parameters, and you can use that to stretch the tool to meet unique project requirements. So of course, when you go to the manage ribbon here, you can always create a lot of new parameters. They can be project parameters, they can be shared parameter and whatnot. You can create as many parameters as possible that you can use to stretch these tools beyond what is currently available. So now you can use schedules for system analysis in Revit.